let's begin with our segment here with the questions and comments that people made since last time. And the way I'm going to begin today, I'm going to start by defining an important word that we're going to need today. And it's this word idiot, idiot. Idiot, idiot, you can pronounce it any way you want. It's an individual big ideas. We call them idiots or idiots, right? Comes from the ancient Klingon, meaning big idea. You have little ideas, just ideas. Then you have idiots, right? Big ideas. And some of these people, just about all of them, think that math has something to do with physics, okay? And I think we're going to set them straight today. Okay? Yeah, no. Math has nothing at all to do with physics. In physics, we do not use math, okay, at all. Numbers, equations, we don't use any of that, okay? Not in physics, okay? Now, maybe they use it somewhere else. Certainly not in physics. And that's what we're going to show today. So we have our first candidate here, visitor. He says, math is not the language of science, but yes, it is the language of physics. Okay. Where have you been for the past few hundred years? You can make physics what it isn't. You can't make physics what it isn't. What you're looking for is natural philosophy. In the 17th century, they used to call this so-called science. They called it natural philosophy. What did that mean? Well, it meant that, they were trying to figure out how this universe works. That gradually evolved into experiments and equations, measurement and equations. And the question is whether experiments, measurements, and equations have anything at all to do with physics. Okay, that's the question. And so the first thing we need to realize here is that this fellow did not define physics, so we don't know what he's talking about. Until he defines physics, we won't know that what he says there is true, or that it's rational, or that it's consistent with what everybody understands for physics. Okay, and by everybody, I mean everybody except the mathematicians out there. Okay, so he forgot to define physics. Aristotle defined physics. He's the guy who invented this word. That's where we got the word from. And he didn't define it as it's defined today. So that's the first thing you should know. The fact that the mathematicians changed the definition in the last 400 years doesn't mean that we can't change it again. Okay, we can change definitions. What if we find that they are irrational? Okay, the ones that these people are using. Okay? In science, we don't care what the mathematicians call physics or whether they all agree. If it's irrational, science rejects their claim. So, you can't use authority here and say, all the mathematicians on Earth voted for the definition of physics. That's what they do. That's what they call physics. We don't care. Science doesn't care. Okay? Physics is whatever rational definition of the word physics says it is, okay? And you don't have to like the definitions. All you have to do is propose one that is more rational, like a better mousetrap. Otherwise, you have to keep your trap shut because you have nothing to offer science. Okay, and this guy says also 99% of humanity doesn't know what the difference between description and explanation. I don't think he knows either, but, how do you explain with math? He's insisting on math. How do you explain with math? So if physics is about explaining, and this guy says that we use math in physics, then the question is, how do you explain with math? That's all he's got to do, explain that. Okay, another fellow says, science and physics is about understanding nature and universe. Understanding, here means explanation of causes and mechanisms. That's what an explanation is, not mathematical descriptions. So he continues, he says, in science, engineering, and physics, we use mathematical representations to help describe and explain. Absolutely not, okay? Math has no power to explain anything, okay? Math can only describe quantitatively. And in science, the question then is physics about explaining or is physics about describing? Okay? And one of the problems there that we have, some people have out there, what do you call them? Idiots, okay? And what do they say? They say that an explanation is just a bunch of descriptions, a listing of descriptions. We're going to debunk that today. And by debunk, I don't mean we're going to convince you and persuade you to believe. That's not what we're here for. Belief belongs in religion. Debunking here is in a different context. Debunking means we define terms, and then using those definitions, we use them consistently, and we show that logically something fails, a theory or whatever. Okay? Now, you don't have to agree to those definitions, but again, that means you have to propose a better mousetrap or keep your trap shut. Okay? Because you don't have anything to contribute to science. Okay, here we have mathematics. Yeah, is correct, probably. It's just a description of the universe, just as the menu is not the dinner. You cannot eat the menu. Okay, mathematics is not reality, just a description of reality. If mathematics and logic are the only things that enable you to describe the universe, what guarantees you that there is a deeper infrastructure than the mathematical description? Well, the first thing is, what does description have to do with physics? What does, unless you define physics, tell me what the definition of the word physics means, all that is worthless, nonsense. You haven't said anything because you haven't defined physics. And then what is this nonsense about deeper infrastructure? What do they use these people are not even in the ballpark. They don't even know what questions that. They don't know what they're supposed to be investigating, researching, what they're supposed to come up with theories for. Okay? And so a rational individual seeks an explanation. That's, I guess, the deeper infrastructure that he's talking about. Okay? The underlying causes, mechanisms of gravity, electromagnetism, atom, the workings of the atom, etc. That's what a rational individual wants to understand. Now, people who do math, they don't care about any of that, and that's why they don't understand even what the questions are. So when someone says, why does this pencil fall to the floor, Why does it fall to the ceiling? And they don't understand the question. Why are you asking that? It never occurred to them to ask that question. Why do things fall to the floor? And so this is where the problem is. This is where it starts and where it ends. Okay? Because these people are thinking in other terms. They have other garbage in their little tiny brains, ant brains. Okay, so here's another fellow says, math may be a language, but it's also a form of proof. Proof. What proof got to do with anything? Proof, it belongs to religion. Proof means they convinced you of something that now you have been recruited. That's what proof means. Okay? What is proof to you is a lie to the guy across the street. He has a different proof, that goes completely against what your proof is. Some people think it's space-time began with Big Bang, and other people believe that God made the whole universe. So there's different proofs out there for different people. We don't use proof in science. You should know that by now, unless you studied at the Cambridge Monastery or the the Harvard Cathedral. Maybe you studied divinity studies or something like that. I suppose you could say physics is more about data. What are these people thinking of? These people have no clue what they're even talking about, okay? Than it is about properties of a thing or action. Regardless of all of them require math to confirm or deny. I guess he's talking about opinion. What Popper said was, falsifiability? Maybe that's what he's got going through his tiny brain. I mean, all these mathematicians, they have no clue whatsoever what the issues are. They're not even on the same page. They're not even in the same planet or in the same universe. I mean, who knows where they are? And here's a last one says, seems to me normal human language is insufficient to describe phenomena with precision. We don't describe, and what does precision have anything to do with anything? We don't use precision in physics. This is as precise as it gets. You let go of the pencil, and it doesn't go below the, in this case, the table, but it doesn't go below the floor for some reason. You know, it doesn't crash through the floor and go all the way to the center of the earth. That's as precise as it gets when, you know, the pencil hits the floor. That's very precise, okay? If you need high precision, what else is there if not math? Well, we don't need high precision. We don't need precision at all. Precision has nothing to do with physics, okay? So let's get it right. So, yeah, again, neither precision or accuracy have anything to do with physics, and you're not even in the ballpark. Says, if math is not the language of physics, then what is? English, German, Chinese? Well, you can use any language, really, to express physics, okay? Because as long as you state qualitatively, you know, you explain a mechanism, a cause, you're okay. We won't hurt you. You know, this is how we do justice here. We use the dough roller or good old Excalibur there. We stab you with it, okay? So, you can use any language. Okay, but make sure it's qualitative instead of quantitative. Then we have there the definition. What is physics? Explanation of causes and mechanisms. Got it? We need an explanation of cause and mechanism. We want to know why, what causes this pencil to fall always downwards, never to the ceiling. What causes the moon to be so faithful to the earth instead of flying out of the solar system? Same for the earth, flying out of the solar system, you know, away from the sun. What keeps it? What prevents the electron bead from flying outside, you know, the atom? That's what we want to understand, okay? And so we need a mechanism, a physical mechanism, not one using concepts. Again, concepts, black magic, okay? We don't use concepts. We don't move them around. You have to put a physical entity there, okay? Let's make sure we understand that. Therefore, the language of physics is illustration. Anyone who cannot make a movie of his mechanism, you know what a mechanism is? Like, you know how a car works? If you cannot make a movie of that, you're not a physicist, okay? So you should be able to make a movie of any mechanism you propose, because mechanism hopefully involve objects, not abstract concepts, okay? So we're talking about mechanisms, we're talking about causes, and we're saying that the language of physics is illustration, not math. What do we use math for? Math is only going to quantify something. It's going to give us a measurement, and you're going to put it in the equation and say, well, this is the description of its motion, so to speak. Yeah, that's like saying you can describe a chair. A chair has 4 legs, mathematically, right? 4 legs, 1 backrest, 1 seat, and maybe 2 armrests. Great, I described it mathematically. And is that physics? Is that science? Okay, so this is the issue. No, we have no use for accuracy or for descriptions in physics. We explain in physics. What do we explain? Causes and mechanism. So we have to go a little step backwards for these slow folks. What? Because they never learned anything in college or in high school, wherever they went. You know, they went to these monasteries, I get these PhDs in divinity studies or whatever, and they never learned what explanations are, what descriptions are, and what the differences are. So let's go into that. What is the difference between a description and an explanation? Okay, here we go with the first one. Okay, these are the proposed definitions in science. You don't have to agree to them. You just, we don't agree, by the way, in science. We don't even agree to disagree. There's no such thing as agreement in science. That's religion again. In science, we don't agree. What we do is we define. And we defend our definitions. You don't like the definition, no problem. You propose a better mousetrap or keep your mousetrap shut. Okay, description, a listing of the properties of an object, image, or scene. You have a static image, static object, static image or scene, and you're going to describe it. What are you going to use? You're going to use primarily adjectives, okay? That's how you describe, because it's a static scene, nothing's moving. You should not be using verbs or adverbs. I can't imagine using that, but maybe there is some situation where it does. But in general, you're going to be using adjectives, okay, because you're going to be describing images that are in front of the person's eyes. Now, what's objective is what comes out of the screen, okay? That's objective for all of us. Now, everybody interprets maybe something different from the screen. That's subjective. Okay, but objective is what comes out of the screen. That's what we call objective. Okay, and it doesn't mean that you said, well, I saw it green. The other guy said I saw it red. Well, that's subjective. Okay, narrative. We like that word, narrative or narration. Description of motion. Okay, because there are descriptions where you don't have a fixed static screen. You have, so to speak, a film strip, a movie, right? And using a chronological way, right? So if you tell a little story or something that happened, well, just objectively, right, you go step by step and you say, this is what happened first, this is what happened second, this is what happened third, without giving your opinion, without giving your a theory. You just say, look, this is what I saw, objectively. Okay, and that's called a narrative or a narration. Explanation, something totally different. Explanation, physical interpretation of causes and mechanisms underlying a phenomena. That's what it is for physics. In philosophy, explanation, which is the other branch of science, by the way, interpretation of the reasons and purposes behind an action. Okay, why did someone do something? Okay, and we're going to see a couple of examples today. Explanation answers why questions, whereas description usually answers how questions, okay, when they're narratives or narrations. Explanation answers why questions, and synonyms, physical interpretation, theory. Okay, so every time you say theory, you're not talking about description, mathematical or otherwise. You are talking about an explanation, okay? Okay, so here we have a couple of examples. Maybe we can illustrate what I just said, okay, so that we can, all zero in on the same notion that we're trying to convey here today. Here we have a car crash, okay, and so the cop says, what happened? The gal goes out, blah, 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 says, and the red car struck the blue car. Well, that's not a description. It's already an explanation. It's already a theory. She's giving her opinion of how it happened. And not only an opinion, she's giving you an explanation, a theory, what she thinks happened. Okay? And so, yeah, the cop just wants the facts, and she's not giving him the facts. She's already interpreting. Okay? No, she should say, look, two cars crashed, or the blue and the red car crashed, or they bumped each other. That's a description. Okay? You're just not giving any opinion, no theory, you're just saying they crashed, okay? The theory, that's for the, lawyers for the insurance companies. The red car says, this guy, the blue car says, the red car crashed into me. And the insurance guys on the red car say, no, the blue car backed up and hit me from the front. And then two others come in there and they have different theories. They say, look, there was a chain underneath the blue car and then pulled it backwards and hit the red car. And the other guy said, there was a chain tied to the red car to a truck, and the truck moved forward and hit the blue car. And they have all these theories. Okay, those are theories. Those are explanations of what people think happened. Okay, that's the issue. But objectively, you have to say two cars crashed. That's a description. Explanation is when you say what she said, the blue car or the red car hit the blue car. Then you're giving a theory, okay? Okay, let's look at another one here. Probably a little more closer to the land of physics. Really, it's from religion, but it's a physical interpretation, okay? Here it is. We have God, okay, and here's our universal movie. What's a universal movie? Well, that's our tool that when we use where everything within a single frame is static. In other words, everything within a single frame, all we have there is location, objects, distance between the atoms in the universe. Everything in the universe is in a single frame there. Every object in the universe, okay? And we propose that matter is finite in the sense that it's countable. In other words, there's not an infinite number of atoms in the universe. Okay, there can't be. But that's the assumption that we start with here. Anyway, the point here is that God has nothing in that first frame on the left, and then on the second frame, the one in the middle, suddenly we have the earth, what they call the world, right? And we have Adam and Eve. So he created that, maybe in 7 days. I showed only in 1 day, but he was creating one thing at a time, and that means that from zero, suddenly we went to something, okay? From nothing to something, okay? That's the religion version, at least from Christianity, okay? And here's the version from so-called science, mathematical physics, meaning, what do we call that? Religion. It's not even religion, it's irrational. So it's not even religion. Religion has a upper hand, a traditional religion like Christianity or Islam, etc. They have a little edge over mathematical physics because at least they deal with what seem to be objects. You know, they talk about God and they're thinking about this magician, human-like magician. They say he looks like us or we look like him, right? And so we more or less get the idea, at least, that the objects are there. Now we have to explain how that magician made something from nothing. That's another issue. But in the case of general relativity, which is the one that talks about the creation of our universe, you know, we got a problem because we got this situation here. We have nothing in the first frame, and suddenly we have this singularity, a little dot. I'll put it as a white dot in the frame number 2, and eventually in frame gazillion over there, you know, you have our universe today, right? What they paint as the W map thingy. Okay, so the question is, we're going to look at frame number 1, number 2. Those are the ones we're interested in. And the problem there is they always start at frame number 2. They say, look, the singularity, and suddenly it exploded, and blah, blah, blah. Okay, great. How did the singularity get there? How did we go from frame 1 where there's nothing to the singularity where there's something? Or was the singularity there for eternity, and suddenly, for whatever reason, it decided to explode? So, and the way they answer that is they say, well, it's an unscientific question because we have no way of proving the hypothesis, the theory, what came before the singularity or how it got there. Yeah, that's the only thing you had to explain. I mean, they have this nonsense where, you know, they take the reel back. They say all the galaxies were closer together yesterday and even closer the day before. And so they take the tape all the way to square one, and they say, really frame 2, and they say, okay, all this was crunched into a singularity. Yeah, we want to know how the singularity got there. I mean, if you can't answer that, your theory is bunk. It's garbage. I mean, that's the only question you got to answer, how the singularity got there. That's the only one we're interested in. The rest is nonsense. And to say it's unscientific is just skirting the question. Okay, so here's another issue here. Here we're going to show an explanation, I guess. Let's find out if it is. Okay, we have this. We have a motor, an engine, right? And car engine. And it talks about the oil, how it goes through there. And so it says, first sentence there says, motor oil is used to lubricate moving parts, clean, prevent corrosion, etc., right? Then that second one, oil galleries, are channels that carry oil to various engine parts. And then the next one says, the oil filter removes unwanted material from engine oil. Then the oil pan holds the engine oil. The oil pump keeps oil properly pressurized and flowing through the engine. So people say, see, Bill, you were wrong. Obviously, this is an explanation. It's a bunch of descriptions, right? Well, no, it ain't, okay? People confuse these things, and so we need to understand exactly what's going on here. This is a great example. Let's look at that first sentence again. Motor oil is used to lubricate moving parts, right? Okay, so the question is the following. What question does that serve as an answer to? Okay, what is the question? And the question is, I'll rephrase it, okay? Why did John lubricate or use motor oil to lubricate moving parts? And the answer is, yeah, the oil was put in there to lubricate the moving parts. So we're answering not a question of physics. We're answering a question of philosophy. We're answering a question that involves not causes and mechanisms. We're answering a question that involves purposes and reasons. And then you have two on the bottom that I put. Philosophically, we can say this is what we're trying to answer. John oiled the parts so they would move. Okay, that's a question of philosophy. That's not a question of physics. It's why did John? What was the purpose, right? What was the reason that John did something? And in physics, you would phrase the maybe in this sense, because you're trying to figure out a why question involving causes and mechanism. You would say parts move because they are oiled. Okay, that's an issue of physics. The other one is an issue of philosophy. And when you say motor oil is used to lubricate moving parts, you're rephrasing a philosophical question, and people confuse this as a statement, a description involving, in this case, oil. Okay, it's not. Okay, it's a theory that is phrased in a way that it sounds like a description, and this is part of the problem. You got to keep in mind how it's phrased and what question you are trying to answer with the statement that you could consider a description. Okay. Here's another case, and I showed this the other day. We have this fellow here, and his name is Casimir. Okay, Casimir is pulling on a donkey. That's what it seems like, right? But we're not going to talk about the theory here, so we can't use the word pulling. We can't use the word pulling because if you say pull, you're already giving a theory, okay? What we're looking at here, we're looking at description only, okay? Let's just talk about description. What can we describe? Well, we can say, and we're assuming this is just standing still. Well, we have a donkey on one side, and we have a rope tied around the donkey's neck, okay? And we see this fellow, okay? And what he's doing, we're going to call it a narrative or narration. What he's doing is moving his hands along what appears to be a rope or a cord or some elongated object. That's a description, okay? And now you say, well, Bill, it's obvious that, what you're illustrating there is that Casimir is pulling on the donkey. That's how the donkey went from A to B. That's how the donkey got closer to Casimir. Okay, well, not so. See, I have a different theory, okay, and I'm going to make something else visible here so that you can understand my theory, okay, and it's air, and I'm going to say, look, there's this wind behind the donkey. It's pushing the donkey towards, the Casimir. So there's a different theory for this phenomenon that you're staring at there. Someone might say, look, Casimir is pulling on the donkey, and another person might say, oh, no, it's the wind pushing the donkey from behind. In fact, you have all these people who talk about pushing gravity, and this is what they're thinking about. So again, when you use pull or push, you're giving already a theory. That's not what you're supposed to do when you describe, okay? So keep that in mind. Let me get rid of this one here. Okay, what if we had no rope? Okay, like we showed the other day. So we see this from afar. Maybe your eyesight is not good, so you can't see what Casimir is doing there. You're only seeing his hands move. You're seeing the donkey comes closer. We have no air or rope, or at least you can't see them. And so the question is, now everybody's baffled. Everybody says, how did the donkey come closer? I don't see anything there. And only because you can't see, you're assuming there's no physical object acting on a donkey. Okay, so this is the issue. The only issue here is that you can't see, subjective, right? You can't see or touch, maybe, whatever is in contact with the donkey, which is the same thing that we have when we let go of the pencil, right? You can't see or touch the whatever's pushing or pulling on this pencil. And so because of that, you say, oh, gravity, we cannot explain. We'll never be able to explain it, or someday we'll be able to explain it in the future. So you kick the can down the road. So you never explain it, because all you have to do is identify the invisible object that come in contact with a pencil, and then it's kid stuff. Then it's baby stuff for kindergartners. 10-year-old can understand it. Okay? But unless you put an object there, if you just keep doing math, equations and measurement, you're never going to figure out the cause, the mechanism that underlies gravity. And that's where we stand today. In 2,000, 3,000, 4,000 years, nobody has figured out how gravity works, what the mechanism is of gravity. And they give you some irrationality, such as, warp time, and what is that? What kind of, is that an explanation to say that time is bent? What is it? The seconds are bent, the minutes, the years. Okay, yeah, so all you have to do to explain, you got to put the rope in there, and then you can give an explanation. Doesn't mean people will believe it. It just means that what's going through your mind is this, that you're saying that the reason the donkey came closer to Casimir, your theory is that he was pulling, on a cord. Okay, so that's the theory. Okay, then you can talk about pull, because now you're giving a mechanism. Okay, so this takes us to this word object. Okay, and this is what keeps everybody from understanding. People think that an object is that which you can see or touch, and see and touch are irrational criteria for the definition of object. You cannot use see or touch, and these are the reasons. You can't see air. Okay, for example, even though it's made of atoms, same as your chair. Okay. You can't see the Klingons table on the other side of the universe. Then you see the picture on the right. You can't see that because he's a gazillion light years away from you. And does that mean that that's not a table, that's not a chair, that's not, there's nothing there? And you say, well, yeah, I have the potential. Has some of these, idiots, whatever. That's what they say. They say, look, I have the potential. It has the potential to be touched. Yeah, but that means that until you touch it, it's not an object. A table is not an object. The word table doesn't refer to an object. When you see it in the dictionary, you see the word table, it's not an object. Of course it is. Table is an object everywhere in the universe, in every dictionary in the universe. It's a thing. Okay? So the question is, you can't say that because you can't see or touch it using that criteria, it's not an object. There are objects you cannot see or touch. And among them, we include the rope. Okay, so it's not a question of seeing and touching. And see and touch also require an experiment, and it involves two objects. You need two objects. You invoke two objects to define one, the word object. Great. And then the question is the asteroid not an object before it strikes the moon? Is the moon not an object before the asteroid strikes it? And so, we can see these two things out there. We see the asteroid coming towards the moon. We say, well, they're not objects until they touch each other. Okay? And yes, see and touch are subjective definitions because they depend on the observer. You need two objects. You need one of them to see and touch the other one. So you need an observer. And that's why it's a subjective definition. On the other hand, object, that which has shape, which is a scientific definition of the word object. My greatest contribution to science, by the way, not so much because I defined it, but because I found out how important the word object is to science and to physics. You can't do physics without an object. That's how simple it is. And it's subjective. Why? Because all objects have shape. If you can think of an object that doesn't have shape, please let me know in the comments section. Okay. So here we move on and we find out why haven't they figured any of this out? Well, because they never defined the word physics. They don't know what physics is. They have only irrational definitions for physics, mathematical physics, and what's the other one there? Theoretical physics. So we have theoretical physics, mathematical physics, and physics, and they all mean the same thing. Here's the first one. Here's physics says, the natural science of matter, involving the study of matter. No. No study. We don't study in science. Okay, anybody can study. Even babies study in kindergarten. Does that make them scientists because they study? So studying is the wrong criteria, the wrong word to use to define any discipline out there. Okay, especially physics and science. Okay, and it's motion and behavior through space and time. Through time. We're traveling through time. How do you travel through time? Is time a container and you travel through it? Is it a tunnel? What is time? How do you travel through time? What does that mean? And the related entities of energy and force. Energy and force belong to the religion of math. It has nothing at all to do with physics. We do not use concepts. We don't transfer energy. We don't push the force or pull it. And we don't use field. We don't vibrate the field because these are all concepts. Okay, so none of that belongs to physics. We don't use foul words, four-letter words such as energy and field and mass, not in science. Okay, physicist, a scientist who specializes in the field of physics, which encompasses the interactions of matter and energy at all length and time scales in the physical universe. What's a scientist? A person who researches. That's in Wikipedia. What's a physicist? A person who does research. Collins Dictionary. No, we don't study, we don't research. We don't do any of that stuff. Not in physics, not in science. Okay? Anybody can do research, anybody can study and learn absolutely nothing. In fact, not even write a paper. So the guy studies, the guy did research, and we leave it there. Oh, I did research, I'm a scientist. No. Study, research, bad words, irrational terms for definition of disciplines. In paleontology, we don't study. In biology, we don't do research. What we do is we explain. When you come to the conference, people don't ask, did you do research? Did you study? Yeah, I studied for the test. I got a 0. Great, you're a scientist because you studied. No, you got to explain. If you don't explain, it means you haven't used the gray matter in your head. Okay, what does theoretical physics say? It says a branch of physics. The tree, it's got a tree branch that employs mathematical models. Absolutely not. Well, maybe theoretical physics, whatever that is. In science, we only have physics, no theoretical physics. And abstractions of physical objects and systems to rationalize, explain, and predict natural phenomena. Explain, math has no power to explain. And predict, that's astrology, palm reading, one of those. And there you have it. Mathematicians are like Mary Poppins. You have Mr. Banks, he was the banker, okay, where she worked, taking care of his 2 kids. And Mr. Banks stops her because she did some boo-boo with 2 kids. And said, will you be good enough to explain all this? Mary Poppins says, first of all, I would like to make one thing perfectly clear. Yes, I never explain anything. And that explains or describes mathematical physics and theoretical physics. They never explain anything, just like Mary Poppins. No different. Okay, and now we have the last one, which is mathematical physics, whatever that is. Mathematical physics refers to the development, blah, 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 for such applications and for the formulation of physical theories. What's a theory? An explanation. Math does not explain. We're done. Okay, we're done. Period. Punto. No theories, explanations in math. We have no theories or explanations in math. Physical refers to objects. So if you don't have an object, you're not doing anything physical. And math never uses objects. Math replaces objects with concepts. Point mass. They take the whole elephant, they weigh them and say it's got a mass of, 5 tons. And so they take the 5 tons, put it in a little dot and say the elephant moved. No, you move the dot, not the elephant. You want to move the elephant, you got to put the elephant back and replace the dot with the elephant. Then you can move the elephant. You can't say because you moved the dot that 5 tons moved, which is what they say. Okay, so math cares not iota about structure. Okay, so here we have it. My definition. This is the one we propose for science. Science, what is the definition? Rational explanations. Very simple. Okay, and rational, there's several criteria for the word rational. We usually define the word irrational, so that's easier to understand. You move concepts, you don't define your terms, or you define terms inconsistently, meaning, you clean your nose holes with your definition. The theory doesn't follow from the hypothesis, from the assumptions, okay, etc. There's a couple more. And so that's what irrational is. And explanation, we just went over that. It's essentially the interpretations. You're going to explain something, and that's called also a theory, okay? Especially, gravitational and electromagnetic phenomena. That's what we're interested in. Why? Because those are invisible and intangible. See, we figured out all the tangible stuff. It's the invisible, intangible stuff that we cannot answer. The mathematicians cannot answer. Why? Because they never proposed objects as mediators. And they say, I can't see or touch it. And so that's when you have to get the definition of object straight. That's why the definition of object is so critical, especially in physics. You can't do physics without the definition of the word object. Okay, so closing up here, math is a language, okay? It's exclusively a quantitative language. Math can only describe. Math has no power to do qualitative stuff, okay? Yeah, it's a question of math cannot do lit. It can only do tit, okay? Hope you got that. Math cannot be used to provide physical interpretations. One branch of math deals with measurement, which is only description, right? Distance, for example, meters, time, seconds, weight, kilogram, speed, miles per hour, etc. Okay, so that's what we have. Those are just descriptions. That's all that math can do. Physics, on the other hand, is exclusively qualitative. Definition is rational explanations of causes and mechanisms. Okay, we got all that? Okay, so here we have another fellow who asks a question or makes a comment. He says, if a tree falls in the forest and there is no one around to hear its sound, will it make a sound? The answer is no. Well, okay, why? Because the most accurate definition of sound, accurate. Why do they talk about accuracy? What's accuracy have to do with anything? It's either rational or irrational, and this one's irrational, what he's going to say here, so we don't have to worry too much about it, but let's have a laugh here. Definition of sound is not that sound is waves in the air, but rather is the relationship between the vibration of the air and the eardrum. Rarefaction and compression, right? If there is no eardrum, there will be no sound. Okay. Good luck convincing a deaf person who does not have an eardrum that sound vibrates while it doesn't even have access to test. Well, he doesn't even have access to test the sound. My God, poor fellow. I guess he studied at the monastery as well. Okay, so here it is. What we do in science, we kill the observer. There are no observers in science or in physics. We have to kill the observers. No witnesses are allowed. And this fellow thinks everything's about what the person heard. And so here we have a deaf person next to you, and you can hear the sound. The other guy cannot hear the sound. So his answer is, well, there is no sound because the deaf person cannot hear it. And so, yeah, he doesn't have the slightest clue about anything, where this guy studied, maybe at a monastery, who knows. Anyways, let's set him straight. Sound is what the forest makes. Okay, the tree falls, makes noise. That noise is called sound, vibration already of the air that surrounds us, right? Now, what you're that's objective. That's a objective definition of sound. Sound is what something makes, the vibrations in the air, right? Now, whether you can hear it or not, that's a question of, otherwise, there would be no sound in the universe because we can't hear all the sounds that are in China, and they can't hear all the sounds we have over here. And so I guess there's no sound in the universe because nobody can hear what the other guy has because he's too far away. Is that your logic? So no, sound is what the tree made when it fell. Whether you can hear it or not, whether whether your friend can hear it or not is irrelevant. Whether the deaf person can hear it or not is irrelevant. Okay, that's an observer-related notion, definition, and of course it's irrational because you're putting an observer. There are no observers in science, especially for no definition. We do not use observers in any definition. As soon as you do, it becomes subjective, and it means it's your opinion against mine. That's why we never put observers or witnesses or whatever you want to call them in science. Okay. Okay. Give me a second here. Okay. So we have another fellow, and he says the following. He says, I think it's the same fellow, but I'm not sure now. The definition of the existence of a thing is a relationship between the existing thing and the observer. Again, we introduced the observer, right? These people want to introduce subjectivity in everything. They say, look, it depends on what the observer measured, what he heard, what he saw. Again, they introduce the observer because they think in subjective terms. They're doing more psychology and psychiatry than they are doing physics. The universe is merely a product of the mind. Oh, is it? So when I die, the universe dies because it's the product of my mind, right? There's no universe for you. Everybody has his own universe, right, in his mind. Is that what it is? Merely a product of mind because there is no universe without someone saying that the universe exists. Well, the universe cannot exist because the word universe is a concept, and concepts cannot exist in science, specifically in physics, okay? It has to be an object. The universe is not an object. The universe is a concept. That means atoms or matter, if you want to say it, matter and space. That's the universe. Two things, even though space is not a thing, but it's treated as a thing in the definition of the word universe. Suppose that there is something in the universe that is impossible for any observer to observe. Yeah, exactly. What if you don't observe it? And so he said, no one can even observe its effect or monitor any information, blah, blah, blah. It is isolated from the rest of existence. Okay, great. But it still exists. Okay, depending on what you mean by exist. Have you defined the word exist? Of course not, because nobody has in the last 10,000 years. I had to be the first person to define the word exist because nobody thought that it was so important. Among them, atheists, theists, and agnostics who go around in circles talking about whether God exists or whether God doesn't exist, and they never defined the word exist. Nobody has any idea what the word exist means. You look at the dictionary, all you find is synonyms, being and reality and just synonyms. We don't have any idea what the word exist is until now. Now we know what the word exist means. We have a rational definition. Exist has to be an object that has location. Okay, if it has a location, it's got an object that has location. It exists by definition, not because I say so. Okay, you don't have to agree to the definition again. You have a better mousetrap. Show us or keep your trap shut. And it says, okay, for us, there is no difference between the existence and the non-existence of this thing. Well, again, you have to define exist. Is it an object? Yes. Then it's got a chance of existing. Does it have location? Yes. Now it exists. If it has no location, it doesn't exist. If it's not even an object, it certainly doesn't exist. See how simple it was? Very simple. No observers necessary. No provision for observers in the definition of exist. For us, there is no difference, right? In this case, existence and non-existence have the same definition. Yeah, that's his conclusion because he never defined the word exist. Okay, so what do we say to him? Well, again, here it is. Okay. The mafia principle. We kill the observer. No observers in science, first of all, and no observers in the definition of exist. Okay? So keep that in mind. Exist simply means an object that has location. If it meets those two criteria, like if God is an object and has location with respect to all atoms in the universe, then God exists by definition. Okay? So if that's your proposal, if that's your assumption that God is a physical object and has location, hey, you've already made God exist for the atheist, for the theist, and for the agnostic, for all of them. All these religious people. Okay, here's fellow who says the following: there needs to be a mediator for gravity, otherwise it's nothing but magic, like quantum entanglement. Yeah, so what do you propose? I mean, draw it. I need to see an image of it. I need to see what object you propose. And the question is whether that object pulls or pushes, because those are the only two possibilities, right, for gravity. Either you push maybe with particles, right, or you pull with some elongated object, I would think, right? But maybe you have a different version, different theory, no problem. You know, put it forth. Draw your thingy, whatever it is, the mediator, and tell us whether it pushes or pulls. Very simple stuff. Okay, and another fellow finally says the following, says, if you release a pencil, it falls to the ground. But if you release a balloon with helium, it rises to the higher part of the atmosphere. He was talking about gravity, right? And yeah, then the question here is, it's no different than stating why you don't fall through the floor. I mean, why don't you go through the floor? Why do you float in water? Or why does a balloon float in, or your rubber ducky? Why do they float in water? And why don't they go through the floor? And, you know, you can say it's density. You can say that the atoms also of, say, the ground or the table or whatever are rigid, you know, and that's why things don't go through them easily, right? And maybe a bomb does. Huh? Density is the antidote to gravity, okay? You have all these people called flat earthers, another idiots or idiots or whatever you want to call them, okay? And they believe that density is what causes gravity. Okay, great, whatever density is, okay? So if the moon were covered in water, you wouldn't be able to fall at 1/6 the gravity on Earth as it is now. Can a pebble fall through the ground floor? Why not? Tell me why not, okay? Is that density or what is it? Can a drop of water sink in the center of the Earth, to the center of the Earth? You know, I mean, you have the ocean. Why don't those drops fall all the way to the center of the Earth? Okay, so you got to tell me that, you know, density, is it the ground is too hard for them? What's the reason here? Are they all pulled by gravity towards the center of the Earth? And there you have the two scenarios, okay? The one on the right is the normal one where you have air and you let go of a piece of metal and a feather there, and it falls very slowly because, you know, you have air, it's going through the air, and air offers some resistance to the feather. Well, it doesn't for the piece of metal there. And on the left, you see there, they took all the air out, and you can see they all fall straight down, like if, you know, gravity pulls on both of them. No density there, okay? So you got to explain that. And here's another version of that. Let me show it to you. Brian Cox, he went to this place, and here it is. Let's see if from the beginning they dropped this. And this is under vacuum. It took the air out, or most of it, and you can see that the feather and the ball fall at the same time. Whereas when it's you know, it's not under vacuum, here you'll see when it's not under vacuum, you'll see what happens. Normal stuff, the ball falls immediately, and the feather takes a long time to come down. Okay, and here you'll see one more time that do falling at the same time because they're under vacuum. Okay, so yeah, you got to answer gravity, and hopefully it's not this nonsense that the flat earthers call density, whatever that is. Okay, again, density is a concept, and they don't understand that. We need a physical object. We want you to tell me what comes in contact with a feather or the ball or whatever, or the metal piece there. Why don't they go upwards? That's what I want to know. You know, why is it the density on the upper side? You know, we have air covering the Earth, right? That's why we can breathe. So why doesn't the feather go upwards? You know, all the way out of the Earth, all the way out of the solar system. That's what we want to know. Please tell us. That's where you would use your brain a little bit. So far, you haven't. Okay, and fellow says, will you ever use your theory to do any real-world predictions, applications? Aha. Wouldn't it be cool project to use your rope model to build a working GPS receiver? Well, what's the answer to this gentleman? The answer is, we do science here. We don't do technology. Okay, and what he's asking is there any practical use for the theory involving the rope, which we call thread theory, by the way? And the answer is no. Science has no practical use whatsoever. People confuse physics with technology, or science with technology. And what do I mean by that? Well, you have people who say that GPS proves general relativity correct, and that computers prove quantum correct, that they're true theories. What do you mean by that? What do you mean the computer proves that quantum is correct? Does a computer, the fact that we have computers, this technology, does it prove that a particle can be at two places at once? Is that what it proves? Does GPS prove that time is a physical object and that you can bend it, which is what the conclusion of these people is? So the question is, does technology prove a theory? And the answer is absolutely not. Technology has absolutely nothing to do with physics, okay, with science. And we have to separate those two things. People have this in their minds. Oh, look, all the technology we have today. We wouldn't have it if all the mathematicians were wrong. Mathematicians have nothing to do with the technology we have today. All technology is developed by trial and error. Or like Thomas Edison said, I haven't, I haven't failed, he said. I just discovered 10,000 ways that don't work. He kept trying one thing after another. Did he know what electricity was? Did he have to know electricity? Did he need to know any math? No. All he needed to do was try one thing after another until he got it right. He said he tried one filament, he tried another one, finally got it right and said, this is the filament. And he made it cheap and available to everybody. And then they came with other filaments later on, tungsten and so on. This is trial and error. It has nothing to do with physics, with explanation. So yeah, the rope model, if it helps you in any way, think in a different direction for developing some technology, well, more power to you. That's not the intention, okay? Physics and science have nothing at all what to do with technology, okay? So these are two different, you could say, disciplines. You can take that to the bank.